Here's the roundness tester, and here's a few balls. This is Aramith Super Pro, and so are these. This is a $5 ball I got off of eBay. It's noticeably smaller, but the weight is actually right on. And this is a Disney set made by Aramith. It's new old stock. It's probably about 20 years old. So here's the plate with the 3 balls. I didn't screw them in, just used hot glue to see if it works. And it's pretty flat. And the ball would go on it like this, and you'd spin it. And here's the indicator, and I'm going to sweep over the surface of the ball. You can see the needle move. Okay, so now it's not touching. So I'm going to move the ball now. I'll put this near 0 just so it's easier for you to see. Alright, so right now so these indicators, you see how it says brown and sharp? That's a brand. So you would say this is 1 on the brown side, and this will be 1 on the sharp side. Each line is a half. So this is 1, this is 1 1/2, this is 2 thousandths of an inch. So right now we're about almost 1 on the brown sharp. So I'm spinning the ball. It's going from 0 to a half on the brown. So I went a full revolution, and the total indicator reading was 1/2 thousandths of an inch. It went between 0 and half on the brown side. Now I'm going to rotate the ball, I don't know, about 90 degrees and try it again. So I'd say that's about the same. It went plus about 1/4 and minus about 1/4 thousandths. So within 1/2 thousandths total indicator reading. Now, this has a lot of flex to it. So watch the needle, if I just push here, you can see it moves quite a bit. That's about 3 thousandths of an inch. So probably some of this movement is just because of flex on this temporary system. So this ball is probably actually better than what it's showing. And this is the finest resolution indicator I have here. I have a finer one at another location, but it's not available now. And just looking at that, I'd say this ball is excellent. And this ball is 10 years old, has a lot of use on it. Now this ball here, it's the Goofy ball, and this is brand new. It probably has like 5 racks on it. So it looks like the needle jumps around less on this one. It's more stable. You can see it's not jumping as much. And here's a ball from the same set, the Super Aramith Pro, but I play mostly 9-ball. So the only time I'm using this is when I practice straight pull, which isn't that often. And let's see what that reads. This might have closer to 1/1000th of total indicator reading. But again, I can't trust this, you know. So that's with this. Here's the other setup. So I just did this just to try it. This indicator is reading about 1.5 thousandths. So each line on this is 1 thousandth. So almost nothing. And one thing with this setup here, because the stand for the indicator, which are these 1, 2, 3 blocks, is so close to the ball, when I push on the base, it moves a lot less than the other setup did. If I put this setup back, so you can see it moves a lot more, but that's because this distance is much greater from here to here. And let's look at the really cheap ball. So this was a $5 ball off of either Amazon or eBay. So we're at 2 on the sharp. So that looks like 1/2 thousandths total indicator reading. And I'll rotate it the other way and then try it again. Maybe 1/2 to 3/4 total indicator reading. And again, if I push on this, so a lot of it's just pushing it with my hand. I'm sure that would go away if I made this out of a sturdier material and did a better design job. But this is just a proof of concept. Now here's the steel ball, and this sucker's heavy. And this has a little bit of grease on it. Yeah, the needle's not even moving. This looks really, really good. Okay, the indicator is 0 on the stainless steel or on the steel ball. And you can see I have a lot of room to lift it up, and it returns to 0. I can lift it up, get the ball out, and then put another ball in. That's reading 6 thousandths undersize. Okay, that's reading 6 thousandths undersize. And this one here, the Amazon ball, the $5 ball, it's reading 14 thousandths undersize. And let's see what they actually measured. So this is supposed to be 2.250. And you can see that's right on the 0. It's 2 inches, 0.250, right on the 0. So this ball is on the money. This one measured, I believe it was, we said 6 thousandths undersized or 4 thousandths, I forget. So you can see it's undersized. That's 5 thousandths undersized. Now it clicked. So this measures about 5 point, there it is. This measures about 5.1 thousandths undersized. And this ball here, that's in the indicator right now, it's measuring 14,000, oh, excuse me, 10, that's 24 thousandths undersize. I was off by 10. So 10, 20, 24 thousandths undersize. So let's see what it measures on the micrometer, which is a true diameter. So you can see how much it is. So here's where it should be. Here's 5 thousandths undersize, 10 thousandths, 15 thousandths, 19 thousandths. So this is measuring 19 thousandths undersize. This is where it's supposed to be. 5, 10, 15, 19. About 19.2 thousandths undersize. And the reason for that is when you measure diameter, you're measuring the two furthest points on the ball. This isn't doing that. You can see the ball, these steel balls, the ball doesn't sit like this. If the ball sat like that, and I put the indicator like this, that would work for diameter. But because the ball sits lower, you're actually gripping the cue ball by its sides instead of by its bottom. So you can't measure diameter directly with this. There's an error. But it wasn't that big of an error. It was, so we said this measured 19 undersize, and this measured 24 undersize. So, what you know, you can go from there. So where are we now? I don't know if it's worth doing anything more with this, because even with this setup here, using the high resolution indicator, I could barely see anything. I mean, it was within 0.5 thousandths of an inch total indicator reading. So certainly if I made this out of aluminum, it would be probably less vibrations, but I don't know if it'll be enough to really tell the difference between a good ball and a bad ball. I'm kind of guessing that even the cheapest of the cheap balls are probably really, 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 really good. So thanks for watching. Let me know if you think it's worth going any further with this. Bye-bye. To add, if I do go any further with this, I think this indicator shows that we need a finer resolution. So I would have to use 1/10 thousandths of an inch. I would have to get that other indicator I have. Otherwise, using this 0.5 thousandths, I don't think it's going to show us much between a good ball and a bad ball.